In 1900, a crew of sponge divers hit a massive storm and dropped anchor near the Greek island of Antikythera to wait it out. Below them, scattered across the seafloor, lay the remains of a Roman-era shipwreck. Look at this pristine bronze statue of a nude male recovered from the site. Exactly what archaeologists expect from classical wrecks. Magnificent, idealized art. Next to hulls like this, a corroded, calcified lump of bronze and wood pulled from the exact same sand, barely registered as a footnote. That lump sat ignored until 1902, when an archaeologist named Valerio Stays looked closely at the shattered fragments. Cutting right through the green oxidation was the unmistakable, precise shape of gear teeth. Finding a manufactured gear inside a 2,000-year-old rock directly contradicted the established timeline of human engineering. The accepted historical record tells us that ancient Greek engineering relied on gross mechanics. They moved stone with levers, built masonry walls, and used simple pulleys. When we picture interlocking teeth and a rope-wrapped spindle, like you see in this large mechanical reconstruction, we are taught that this level of precision gearwork belongs to the medieval clockmakers of Europe, nearly 1,000 years later. Yet, modern dating of the Antikythera Mechanism places its creation squarely between 150 and 100 BCE. The device functioned as a portable astronomical data processor, the world's oldest known analog computer. The presence of this technology in the 1st century BCE introduces a massive, unexplained gap between the capabilities of the ancient world and the documented history of mechanical progress. If you were to look inside the original casing, you would find a densely packed network of at least 30, and likely over 50, hand-cut bronze gears, all driven by the turning of a single external crank. Turning that crank drove a front dial tracking the exact date in the Egyptian calendar, while charting the current positions of the sun and moon through the zodiac. It even housed a physical lunar phase indicator, a small sphere, painted half black and half white, rotated to display the moon's current phase, based entirely on the mechanical angle of the sun gear. But the engineering peaks with a technique called epicyclic gearing, where smaller gears physically ride on the face of larger, rotating base gears. As you can see in this moving diagram, an off-center pin on the primary gear drives a secondary slot. This constant rotational input translates into an accelerating and decelerating path, perfectly simulating the irregular, changing speeds of the moon's elliptical orbit. Looking at this portrait of the 17th century astronomer Johannes Kepler, it's worth noting the timeline. Kepler is the man credited with finally explaining the mathematics of planetary motion, some 1,700 years after this mechanism sank. Ancient engineers successfully captured the invisible physics of the cosmos and machined them into bronze centuries before those laws were formally written down. The back of the device swapped the circular dials for complex spiral scales designed to track massive, long-term chronological cycles. The lower spiral mapped out the Saros cycle, a specific period of 223 lunar months where the geometric alignment of the Earth, Sun, and Moon repeats exactly. By tracking this cycle mechanically, the operator could predict exact solar and lunar eclipses decades into the future. A secondary, smaller dial then tied this vast cosmic math back to human society by tracking the 4-year cycle of the ancient Olympic Games. To ensure anyone could operate it, the builder inscribed thousands of tiny Greek characters across the casing to serve as a built-in user manual. The mechanism collapsed the terrifying complexity of the solar system into a predictable, handheld mathematical model. Historians now believe this device emerged from a Hellenistic tradition, perhaps linked to the school of Archimedes, where scientists successfully merged advanced mathematics, astronomy, and precision metallurgy. Look closely at these instructions etched directly into the bronze plating. The flawless spacing of the gears and the inclusion of a detailed operating manual represent a mature, highly developed manufacturing process. A machine this refined requires generations of trial, error, and established manufacturing techniques. Yet it is the singular surviving example of its kind anywhere on Earth. The fact that the archaeological record is empty doesn't mean the ancient world lacked technology. It means history rarely spares the physical objects we create. In the ancient Mediterranean economy, refined bronze was an incredibly valuable, versatile, and easily melted resource. As empires collapsed, cities burned, and new armies marched, The technological marvels of the previous generation were routinely tossed into the forge and melted down to cast swords and mint coins. The Antikythera Mechanism wasn't preserved in a great library or revered by later generations. It survived entirely by accident, because a violent storm dragged it to the bottom of the sea where scavengers couldn't reach it. If a device this sophisticated was just an everyday piece of cargo, saved only by a shipwreck, we have to ask how far human engineering had actually advanced before we forgot how to build it.